Alright everybody, welcome back. We're going to talk a little bit more about radicals in this video. We'll continue on from where we left off, and we're going to talk about how to specifically add them together and subtract them. There's a couple rules that we got to talk about first, and the analogy that you can use here is to think about things in terms of polynomials. So at the very top, we talked about things in the past that were considered to be like terms. And the way that you can consider something to be a like term is they had to have the same variable and the same exponent. Okay, both of those things had to be true. So if you look at the terms in that expression, you've got some x's, so we'll highlight those together along with the sign in front of them, so a positive 3x and a negative 1x. You've got powers of y, and you also have some x squareds. So those are the things that we could combine, since if you look at their exponents and variables, they happen to be the same if you color code them. So if you collect them by then adding or subtracting your coefficients, right, comparing those, you're going to have 5x squareds plus 2x's plus y. And again, you can just take your coefficients and add them together. So for the x squareds, you've got a positive 7, a minus 2, put them together and you have 5. Okay, so those two things are equal. We've just combined some terms wherever we could. Now, we couldn't combine together x and y terms because they had different variables. And the same reason we couldn't combine x's and x squareds, well, they had different exponents, even though the variable was the same. Okay, so both conditions have to be true, same variable and exponent, in order for us to put them together. Now, when you translate that into thinking about radicals, there are a couple things that need to happen as well. So radicals with the same radicand and index are considered like radicals, just like we had like terms. The radicand again being the number on the inside, and the index being that little tiny number on the outside, telling you what kind of root it is. And you can combine those like terms by adding or subtracting their coefficients identically to polynomials. So there's a couple bullets here to give you a few examples. 4 root 3 and 2 root 3 are like radicals, right? The index for both of them is 2, they're square roots. The radicands are 3, that's the same number under that root sign. These ones, we can operate with them. They do operate. You can add them together, you can subtract them. Okay, those are our operations. The second one, 4 root 2 and 2 root 3, while they're both square roots, they're not like radicals, because the radicands are different. One's a 2, one's a 3. And with these ones, you cannot put them together. The bottom bullet also are not like radicals. One's a square root, one's a cube root. Those are very different. And again, we cannot put those together, so they don't operate together. Okay, before you add or subtract things, convert those entire radicals into mixed radicals using what we talked about last time. Sometimes the radicands won't be the same when you start, but they may turn into the same thing if you turn them into mixed radicals first. And try to keep all those numbers in radical format. Try not to use your calculator to evaluate them. We'll keep them as exact values here. Okay, so let's try a couple of these out. So there are a few, yeah, not too many. So I won't do every single one in here. They'll do a few examples, and again, you can have the full answer key in that description box so you can try them out and compare how you did. So if you think about A, get that out of the way, there we go. So you've got 3 terms here, right? 5 root 2, 3 root 2, and a minus 2 root 2. We're going to put them all together. And the first thing you're going to notice is that all of them have a square root of 2. If you look at the radicands, they're all 2. All of the indexes tell you they're square roots, so this is a really, really nice one. You can just put them together. Okay, use the coefficients to do that. So they're going to be in terms of root 2's. The coefficients will tell you how many root 2's you have. So 5 is the first one, plus 3 comes next, so we're at 8. And then last one is a -2, so 5 plus 3, 8, minus 2 is 6. So in total, when we put those together, we have 6 square root 2's. Okay, 6 root 2's. For B, well, you've got some of them that are like radicals and some that, well, can't be combined with those. So you've got square root 7's, if I look at those middle terms, and then I've got cube root 7's. So 2 of them can be put together, and the other 2 will get put together. So once you have decided if you've got like radicals, take those like radicals and combine them. So I'm going to have 7 cube root 7's, 3 in the first term, 4 in the last term. So 7 cube root 7's. And then I'm going to have in the middle, those two go together, so minus 5 root 7's. It doesn't really matter what order you write them in. Usually you're going to see your higher roots first, and then they just decrease from there. But mathematically, it's no different than saying -5 root 7's plus 7 cube root 7's. They do mean the same thing. It's just nicer to see the one in the colors there with pink and purple, because then you don't have to worry about that extra sign on the outside. It looks a little bit cleaner. So you probably see this one more often. Right. Okay, so if they're already, like radicals, it makes it very nice. The issue is, well, sometimes they're not. Right, and I have 4 different radicals here. None of them have the same radicand. And we said what we could do is make sure that they are like radicals before you even try to add them. So turn them into that mixed radical format that we talked about in the last one. So 12 is the same thing as 4 times 3. 18 is the same thing as 9 times 2. 27 is 9 times 3. And 8 is 4 times 2. Now these aren't the only ways to multiply to these numbers. For example, 12 is the same thing as 6 multiplied by 2. The problem is neither one of those numbers are perfect squares if I use 6 and 2. So I can't actually simplify it the way that I want. So just make sure when you do this that you pick a perfect square to be one of the factors. And what you're going to notice is that if you've done it correctly, you should have some numbers that are the same underneath those root signs. So I know that after I simplify this, the purple ones will go together, because I'm going to be left with 3's that'll make my radicands the same. The red ones will go together, because I'm going to have 2's. Okay, so we'll write this out, and again, if there's 2 numbers multiplying underneath, that square root will apply to each of them when you take the product. So square root of 4 times the square root of 3 plus the square root of 9 times the square root of 2, and so on for all of the rest. There we go. Take the square root of anything you actually can. So we did this deliberately to have a perfect square. So 2 root 3 plus 3 root 2 minus 3 root 3 plus 2 root 2. So I made them all their mixed radical equivalents. And now you can see those 3's that I mentioned before. So there's the root 2's that will go together. And here are the root 3's that will go together. Okay, so now once they're changed, now you can combine your like terms, your like radicals. So we'll do minus root 3 plus 5 root 2's. Or if you don't like seeing that sign, you can do 5 root 2's minus a root 3. Either one mathematically is the same. Let's make that box a little nicer. There we go. So mixed radicals first, then you can combine. Okay, I can't just take the radicands and add them together. The rules don't work like that. Right? And the nice thing about radicals, you can try them out. So if I try to even just think about the first 2 terms, for example, just square root 12, and if I add to it the square root of 18. Just think about those 2 for now. That's the decimal I should get. Now, if I try to do the square root of 30, right, which is 12 plus 18. If you add those numbers together, you will not get the same thing. Okay, so you can't just add the numbers underneath. It's not the same. It doesn't work. If it did, those decimals would be the same. Okay, so mixed radicals first, then combine. So I'll leave B for you to try out, and you'll see the full completed one in the solutions. So you can take a look. We'll talk about a couple. Okay, so this is good. We'll talk about this one here too. So it says write and simplify an expression for the area of the rectangle and the perimeter. Okay, so we'll do, we won't do area just because we'll do multiplying in a future video, so I'm going to save that one. But if you want to try multiplying, again, I'll have it in the key. We'll just talk about perimeter here because I can do that with addition. And if you remember perimeter versus area, perimeter was the distance around the outside, area was the shaded part in the middle. So in this one, the blue part's the area. Around the outside, those 4 lengths of this rectangle, if you add them up, you have your perimeter. Now, if it is a rectangle, which it says, then I know that it has 2 sets of parallel sides. So the other one here is 2 root 3, so they're parallel and equal to each other. And the bottom one is 4 root 2 minus root 3. So these are equal, and the top and bottom ones are equal. Now for perimeter, I could add up those 4 sides. Maybe red's not a good color. So the perimeter says, well, I can do 2 lengths plus 2 widths, and that will get us the perimeter. So if I add everything up, we'll do 2 root 3 plus 2 root 3 plus the 4 root 2 minus root 3 plus the 4 root 2 minus root 3. Now I know there's negative signs in there, but really what I'm adding is the length of that side. So I have to add the whole thing, right? So top and bottom. I have to take the whole term, the whole dimension. But now I can add things. I have some like radicals, which is excellent. That's very helpful to do this. So all of the things that are root 3s can get put together. So a 2 root 3 plus 2 root 3, that's already 4 root 3s. Minus a root 3 is 3 root 3s, minus another is 2 root 3. So in total you have 2 root 3s when you collect that one, that one, that one, and that one. So we've combined all of those for 2 root 3s. And then our last term is only what's left, all the root 2s. So plus 8 root 2s. Okay, there's your perimeter. And again, if you want to try area, it has to do with multiplying. So we'll talk about it in the solution. We'll talk about multiplying in the next video. Okay, so if you want to try it, you can. Or watch the multiplying one and then come back to try it out. Either one is fine. And there's a couple more examples here that we can talk about. I want to see if one is more complicated than the other. I don't think so. They're all very similar. So maybe I'll do the cube root one there, and I'll leave the other ones for people to try out. Based on what we talked about, nothing's any different, but the cube root one can be a little complicated for people. So if you think about this in terms of a cube root instead, the only difference, when you go to turn them into a mixed radical, you're not looking for a number that's a perfect square factor, you're looking for a perfect cube factor. So think about 16, and you can do 8 multiplied with 2, 8's a perfect cube. For 54, you can do 27 times 2. So if you split that root sign up, and remember it's a cube root, so you should keep that index in that root sign, because if you don't, well, it doesn't say cube root anymore, it says square root. Okay, so just like we did before for square roots, no different. Simplify what you can. So the cube root of 8 is going to be 2. And I can't take the cube root of 2, so it stays. Cube root of 27 is 3, and again, you can't cube root 2, so it stays. And what you're going to notice is that I'm left in a place that I have like radicals. Multiply and simplify what you can. So you're going to have 14 cube root 2's from the first term, plus 6 cube root 2's from the second term. And if you add those together now, because they're like radicals, you have 20 cube root 2. So exactly the same as we talked about for square roots, no different. mixed radicals first, then add or subtract. So I hope that helps when you go to convert some things. Multiplying and dividing are they're actually easier than adding and subtracting. There's less work involved. So we'll talk about that in the next video. And like I said, you'll find all the solutions for the other ones if you need some to try out individually. You'll find the links in that description box. So check back for the other one, and we'll see you next time.